Okay, today we're going to look at permutations of R objects from N objects. So, so far we've only dealt with the permutations of all the objects being selected. What happens if we only want to select some of them? So say we have, why is this not working? It's not working. Oh, it's because I've got the wrong colour. There we go. Blue on blue won't work. Okay, so we want our objects from N objects. For example, say we had the letters A, B, C, D and E, and we only want to pick 3 of them. So we would have our 5 objects, and then we divide that by, now let's think about what does that mean. So that's, we only want 3 of them, it could be any 3. So 5 minus 3 factorial, so that's 5 times 4 times 3 times 2 times 1 divided by 5 minus 3 is 2, so 2 times 1. So we're getting rid of those. And if you work that out, you get 60 permutations. So the rule is, if we have n objects and we're only choosing r out of those n, we have n factorial n minus r factorial. Let's do a few examples. So how many 3-digit numbers can be made from the following? So we have 3, 4, 5, 6, 7, 8 and 9. If each is used at most once. So how many have we got? 1, 2, 3, 4, 5, 6, 7. So we've got 7 and we're only choosing 3. So that's 7 factorial, 7 minus 3 factorial, which is 7 factorial over 4 factorial, which gives us 210 3-digit numbers. I'll just do it here as well. Underline that one. And how many ways can 5 playing cards from a standard deck of 52 cards be arranged in a row? So again, there's 52 and we're only choosing 5. So that's going to be 47 factorial, and that's 311,875,200 ways. It's a bit more tricky. And how many ways can 4 out of 18 girls sit on a 4-seat sofa when the eldest girl must be given a seat. So let's think about our 4-seat sofa. So one of these is going to be taken up by the oldest girl, and that can change. That the way of choosing this seat can be chosen in 4 different ways. You can sit there, or there, or there, or there. So there's 4 possible ways that the eldest girl can be seated. And now that leaves 3 places left, but the oldest girl's already got her seat, so there's 17 girls left. So that must be 16,320 ways. Let's do one last question. In how many ways can 4 boys and 3 girls stand in a row when no 2 girls are allowed to stand next to each other? So let's think about let's think about the boys first. We've got our 4 boys, boy 1, boy 2, boy 3, and boy 4. And there's 3 girls, and the girls can have to stand in the middle of the boys, or they can be at the end. So a girl can stand here, 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 or here. So let's think about the boys. They're quite simple. There's 4 of them, and they can be arranged in 4, and we're picking all 4. And that's how they're arranged. To arrange the girls in 3 of the 5 spaces, there's 5 possible places that they can stand, and there's 3 girls to stand in them. So we're selecting 3 places out of the 5 between or at the side of each boy. So this will give us 4p4 times 5p3, and that gives us 1,440 ways. So in this one, we're turning the question around from the girls to selecting the actual position in which they are standing. So I hope that makes sense.